everyone, welcome to the channel. Here's another A-level exam style question, and this one is linked to drift velocity. Please pause the video and try the question. Now this formula I is equal to NAVE is connected to drift velocity. So this I is the current measured in amps, N is the charge carrier density. This is the amount of free electrons or free charge carriers per cubic meter. Now when it says copper has a charge carrier density of 8.5 times 10 to the power of 28 electrons per cubic meter, that tells the number of free electrons in the metallic bonding. Nichrome has a slightly lower number. Area of cross section obviously measured in meters squared. V is the drift velocity. So this is the mean velocity at which the electrons are traveling. Now the thing is this, these electrons are not really traveling along a straight line. So what they do is they travel really fast, but they make a lot of collisions as they go. So their mean velocity could be relatively low. So that is what we refer to as the drift velocity. And E obviously is the charge on an electron, which is 1.6 times 10 to the power of negative 19 coulombs, which is given here. Calculate the drift velocity of electrons in the copper wire. So the question says to give it in millimeters per second. So let's do that. So the drift velocity V is equal to I over NAE. So what's the current? Current is 2 amps. Current is the same through both of them. N for copper. Copper, the value of N is 8.5 times 10 to the power of 28. So let's do that. 8.5 times 10 to the power of 28 multiplied by the area of the cross section is 1 times 10 to the power of negative 6 multiplied by 1.6 times 10 to the power of negative 19. Now when you do that, you get your answer in meters per second. But the question says to give it in millimeters per second. So for some reason, so whatever the answer you get, I'm just going to multiply this by 1000. So for the first part, I get 0.1470588 ... So let's call it 0.15 millimeters per second. Now to do the same thing for the nichrome wire, I just need to substitute the values. Now for nichrome, the value of N is 1 times 10 to the power of 28. So you can put it here, multiplied by the area and E. So in the second part, I get 2.5 millimeters per second. So the answer for part A is 0.15 millimeters per second. Second one is 2.5 millimeters per second. Part C. Compare your answers to parts A and B. Explain why the drift velocity in the nichrome wire is greater or smaller than copper. Now you can clearly see it is significantly greater, right? 0.15 and 2.5. So why is that? Well, there are two reasons. Now, the current through both wires is 2 amps here and current is here. Now, if the current is to remain constant, think about the formula. E is obviously constant. Now, we need the current to be the same, but you can see clearly nichrome has a lower value when it comes to charge carrier density. This is 8.5, this is 1. The 10 to the power is the same. So nichrome has a low N. Also, it has a smaller cross-sectional area. Look at it. Copper has an area of cross-section in the region 10 to the power of negative 6. Nichrome is 10 to the power of negative 7. It's a bit smaller. So you can see it has low area of cross-section and low value of N, obviously, but end of the day, the product of NAV for copper and NAV for nichrome should be the same because it is the same current. Now, the only way to make it up is by having a larger value of V. So here's the full answer. The drift velocity of nichrome is much greater than that of copper. Because the question says greater or smaller, let's specify. This is because nichrome has a lower area of cross section, that's one point, and a lower charge carrier density N compared to copper. But they both carry the same current, so electrons need to move faster to compensate for the other two.